So we're going to go through the review of circles on celebration of circles today. All right, you guys better have this answer circled already. All right, if the radius, and I do have some people who are still messing this up though. Radius goes from the center to the side. If that's 2.6, what's the actual diameter? It's twice as big because the diameter goes all the way across. So it's 2 radiuses. So this would be 5.2. Number 2 says to use this diagram. Refer to the figure of the circle with center T to the right. Name an arc that measures 230 degrees. Well, when I just look at this picture, I can't see anything that adds up to 230 until I start getting some other measurements. So how are we going to get some more measurements? What can we figure out? All right, Abby? Okay, so you're going on this side? Or are you going on this side? Okay, here, this way? All right, so you're saying this is a diameter, so these two add up to, was that what you're thinking? 180? Okay, so let's figure out this angle right here. 180 minus 50 would be 130. Okay, does anybody have another way to get some more angles? What else can I figure out? Darylyn? Say that again? R? I don't see an R. That's what I'm... R. Oh, arc. ED here? That's equal to 50? Okay, gotcha. Vertical angles are congruent. All right, and then how can we get this one? Devin? Evan? See, there's more than one way to get this. So I just heard another way to get this angle. She said these are vertical, so you could subtract 40 from 130 and get 90. There's also the fact that this is a diameter. 180 minus 90 minus 40 would be 90. Whatever I do, that's 90. All right, now let's look for something that adds up to 230. I bet you can find something now. You got 130. 50 is 100, so I'm thinking I need to look around here. So let's just check what they said. PEB. P through E all the way to B. Oh, that would be adding those 3 angles. So that's the right answer, and let's just check the rest. ABC, arc ABC would only be 140. CDE, C to D to E would only be 90. A to B to D would be 180. All right, so A is the only answer that's right. Find the measure of arc PE. Oh, well, the measure of an arc is equal to the measure of its central angle. So this would be 50. If TC is 8, TC, I have to see what that is. TC is 8. That is a radius. Find the length of arc DC. Well, if I want the length of this arc length is x degrees out of 360 times pi times the diameter. I need to plug in the right numbers. I want this arc, so I use the angle measure. The arc measure is equal to the measure of the central angle. So this I'm going to replace with 40. And what's the diameter? How'd you get 16? It's double the radius. So we had to do 2 times 8. All right, put in 16 for the diameter. Grab your calculator and calculate, please. $40 divided by 360 times pi times 16. Okay, we got 5.6. And that would be in inches. Okay, next picture. For exercises 5 through 7, refer to the figure to the right of the exercises. Do not assume E to be the center of a circle. All right, now that's very important, and I really don't like the way this picture looks. I almost wish they wouldn't have a dot where E is, because it looks like it's the center, doesn't it? All right, so we got to ignore that. It looks like it's the center, right? It might not be. I'm just going to look at these inscribed angles and the arcs that they intercept. And I'm just going to start thinking about this. This arc, BC, would be 27 times 2. Let's figure that out. 2 times 27 is 54 degrees. All right, that is arc BC, and that's what they asked us for the first question. So I just did number 1 without even thinking about it. I really didn't know I was doing number 1. Okay, it says, I'm going to start looking at some more numbers on here. You see this 50? Let's look at the arc it intercepts. Right there. How big would that arc be then from A to B? Yep, that would be 100. Okay, now let's go this way. There's a 45 inscribed angle here at ACD, so this one would be 90. 2 times 45. I could go down and get the bottom one now by doing, well, actually, you could do triangle angle sum theorem. That should work, but I'm not sure if it will. But let's go through and do 360 minus 100 minus 90 minus 54. I don't know why I'm doing that. Do I have to find that? I don't even know if I do. BAD. Oh, let's just see what the questions are before I waste time on that. Angle ABP. Oh, this angle is going to be half of that arc. So that's going to be 50. You see why? Half of 100. Okay, and then measure of arc BAD would be 100 plus 90. So it would be 190. I could have found this down here, but I don't think we got asked it anyway. Or is it on the next? Nope, that's it. We didn't get asked. But I could have found this. If I wanted to, I could have subtracted. All right, number 8. Now we have a different picture. It says find AC. I want some help. Why would it be 26? Yes. All right. BC is a radius, CG is a radius, so it's 10. And if I want A to C, and that's 16 down here on the outside, 26 is the answer. Then it says find AB. Well, if I want to find A to B, I'm going to put an X on it. What we need to realize is that AB is a tangent to the circle with center C, and that BC is a radius. If BC is a radius, what do we know about the angle right here by B? It has to be a right angle. Okay, so that means we've got a right triangle. Now, is the 26 the X and the 10? I need to know what parts they are because it's leg squared plus leg squared equals hypotenuse squared. Which ones are the legs? And we were messing this up. This quiz I'm going to return to you after we're done here. It's clear to me that some of you still do not know which ones are the legs. The legs make the right angle. 10 is a leg. AB is a leg. So 10 squared plus X squared equals the hypotenuse squared, which is 26 squared. You don't add, you subtract. Because this is 100, you're going to need to subtract 100 from the square of 26 when you do 26 squared. So I'll write it out. That's 100 plus X squared equals 26 is what is that? 676. Okay, and then you subtract 100 from both sides. And then the last step is to take the square root. So you take the square root of 576 and you find out it's 24. All right, next one. Find the measure of angle DAE. We did not do problems like that. We did not do 10-6, so you can cross out this one because it's not required on the test. I could tell you how to figure it out. It's 15. Did you guess? This is 30. The way you do it, I'll just tell you since some of you figured it out. You take the large arc minus the small arc divided by 2. There's the formula. And that's in section 10.6. 60 minus 30 divided by 2. So that's 30 divided by 2. That's where you get 15. But interesting that you thought it was probably 13. All right. 15. Find the length of arc FE. You do not have to do that. You do not have to know that for the test Monday or in 2 days. Okay, that is the arc we want to find the length of. So that's x degrees out of 360 times pi times the diameter. So let's get the stuff we need. We've got the degrees, it's 90. What about the diameter? It's 20 because the radius is 10. So that's what we want to calculate. 90 out of 360 times pi times 20. Let's see what that is to the nearest tenth. 15.7. And you need, I don't know, there's no label, so I wouldn't mark off for no label. Can't do that. For exercises 12 to 16, we're using the circle with center X. All right, let's see what they gave us. They said AB is parallel to DC. Well, do you remember something about parallel lines cut by transversals? Be interesting. There would be some things that are congruent in here. See, I've got a BC is 98. That's a quadrilateral with a pair of parallel sides. Now, it doesn't mean that these have to be. Let's see. I'm thinking those are equal. Let's find out. We've got AXB is 102. Let me write that in red so we can see it better. Now, what arc is 102? Yep, A to B. Because it's equal to the measure of its central angle. That would be 102. And then I have angle BAC. Oh, see what they want us to find. Find the measure of angle ADB. ADB. Okay, well, that's intercepting the arc that we just found the measure of. If that's 102, then this is 51. Half of 102. So A would be the solution for number 12. Find angle BDC. BDC intercepts the 98-degree arc. So what's half of 98? That's 49. Okay, now next it says, wait a minute, where's it? Is there another angle that intercepts the same arc up here? So isn't this angle also 51? You see what I'm getting at? All right. And then going over here, this must be isosceles, right? See what I'm saying? That angle's 51, that angle's 51. So I'm thinking this is 98 over here too, isn't it? You with me? All right. This is also 49. Those chords were equal. Find the measure angle BAC. BAC. Oh, that's intercepted by 98. So that's going to be 49. And I'm sorry for all the writing on top of there. Just trying to get people to see where I'm getting these numbers from. This thing's isosceles. You see that these are radii right here. So that triangle in there is isosceles. And now that I wrote all over this, could you guys tell me what we're finding on 15? So I don't have to go to the blank picture on the next screen. A, B, C? A, B, C? Okay. So that would be all of that, which, matter of fact, I'll even erase this 98 for a second because I didn't really need it and I didn't prove it. All right. If I want ABC, I need to know that arc. How can I get that arc? Well, I have 98 and 102 over here, right? And let's find out what that adds up to, and then whatever's left would be this length, or that, not length, but that arc measure. So 360 minus, this is 200, isn't it, when you put those together? So that's 160 for this arc out here. And if that's 160, angle ABC is half of it, so it would be 80 degrees. Okay, for 15. And then you want XAB for the next one. XAB. Now that's inside this little baby triangle. Let me show you on the next picture. They're wanting to know what this angle is. You've already got 102 degrees here. That's a radius, that's a radius. So this is an isosceles triangle with a 102 degree angle right there, and these two angles would be congruent. So I'll do 180 minus 102, which is 78, and then what? Divide by 2. That would be 39. So that little angle there is 39, so is the one over here. Oh boy, a lot of stuff on that picture. I didn't freak anybody out there. All right. Next one. What I want you to do, as soon as you see a circle with a quadrilateral inscribed in it, there's a property that you should know. And I have a feeling, because of those quizzes I graded, that I need you to look this up in your ISN. Find this, please. We really need to do. Okay, before we even look at what this says, what do you know about the angles in this figure? All right, Kenny? Opposite angles are supplementary. That's the big deal. All right, so what are opposite angles? And sometimes I wonder if we're really not sure what that means. They're across from each other. So in this picture, angle D plus angle B equals 180. And these two are across from each other. So angle E plus angle C equals 180. You have to know that. Okay, and that's not, should have been able to look up. All right, now I'm going to go ahead and label what they said up here. The measure of angle DEB, 3x. The measure of angle DCB, 2x plus 15. I'm going to be writing all over these in a minute. EDC, 5x. And then they didn't give us anything about angle B. So I'm going to have to figure out angle B some other way. So what ones can I work with right now? E and C. Those are opposite one another, and they are supplementary. So 3x plus 2x plus 15 equals 180. That's 5x plus 15 equals 180. We need to subtract 15 from both sides. 5 times x equals 165. Divide by 5, and we get x is 33. All right, that's just x. They didn't even ask for x. It says, what's the measure of angle DEB? Well, if x is 33, then I need to do 3 times 33. I'm going to erase that now. And I'm going to put on there 99. And I'm going to plug in the rest of these. So 2 times 33 plus 15, that's 66 plus 15. So this angle over here is at 81, right? Okay, and then 5 times 33, please. 5 times 33 is 165. Okay. Let's see what they're asking for. The measure of arc EC. Oh, well, if I want to know arc EC, I probably need the angle B, don't I? Because it intercepts arc EC. All right, so what are the angles of a four-sided polygon add up to? 360. Okay, so here we go. 360 minus 165 minus 99 minus 81. At least that's what how I would approach it. I could have found out some other stuff, but like I could have said this arc's 162 and that one is 2 times 99, and then I could have figured it out. I don't know. There's a lot of different numbers we could get right now. You could also double 165. That would be all of this, and then subtract that from 360. Okay, so what do you got when you subtracted all that? 15? Okay, so that means arc EC is 30. Double it. Got to double the angle. All right, find angle EBC, what we just did. It's 15. And arc DEB is intercepted by this angle. So that double 81 is 162. So 81 times 2, that's how I got that. All right, I took all these problems out, so I believe my numbering is going to be different. Are we at the circles now? Okay, and what number do I have on your problem that looks just like this, please? Because I changed them. I renumbered it for you. 21? Okay. So 21, what you got to remember, and you will have this format to look at, x minus h quantity squared plus y minus k quantity squared equals r squared. In this case, it says plus 6, so the center is not at 6 something. It has to be the opposite of this. So it would be negative 6, and the k value is 4. R squared equals 169. So to get r, you take the square root of 169 and get the radius is 13. 22. What's the center? 8, negative 3. What is the radius? You better not write 225. Unsquare it, 15. 23 is asking us to graph the circle and name the radius and the center. So the center for this circle would be 1, negative 5, and the radius, r squared is 9, so r is the square root of 9, which is 3. You go to the point 1, negative 5, and then you count to the right 3, to the left 3, up 1, 2, 3. That's not as far. Down 1, 2, 3. Why is this not going to look like a circle? What's wrong with this graph? I like hearing that description. Go ahead, say it, Nathan. Okay, this is not evenly spaced. There's a lot wider amount between those x values, he said, than there are between the y values. So those are rectangles, and it makes the circle stretch. It's distorted. All right, center, I'm going to do just 1 or 2 more, and then I'm going to have you guys work them, and then we'll check them. So center's at 2, negative 1 with the radius. Oh, what's the radius? What's the square root of 1? Oh, you better know that's 1. Okay. So the radius is 1. So we go to 2, negative 1, and we go right 1, up 1, left 1, whatever, all over. just those 4 points and make a circle. This one is actually much rounder, but I kind of missed my point, went a little bit too high. Anyway, I just need to see that you plot the center correctly and that you know what the radius was. Oh well. All right, so this is 25, I believe. Did I number it right? All right, go for it. Well, I'm going to go ahead and pass back your quizzes, and then we'll come back and check these.